This one here might not be a little, as a parent as well, you might start thinking like u-substitution and all that kind of stuff. But if you think about it, we really have like a monomial on the denominator. You know, really this is like x to the negative 1/2, or x to the 1/2 is on the denominator, right? So what exactly could we do? Well, couldn't we just split this so that we have that on the denominator of 3 different fractions? So we have the integral of x over the square root of x minus 2 root x over root x plus 1 over root x dx. Okay, so now we just have each of these split, because as long as I keep the denominator the same, I can split up the numerator, right? Okay, so let's just figure out what this is. Remember, square root of x is really just x to the 1/2. So we're going to undo that, and we're going to change this to x to the 1/2. And that one can be the same thing, x to the 1/2. Okay, so x divided by x to the 1/2, remember we just subtract the exponent of the numerator by the exponent of the denominator, so we are going to get just x to the 1/2. Okay, minus 2, because those cancel each other out, and then plus x to the negative 1/2. We're just going to write it that way, dx. Okay, and so now since this is an integral with 3 separate terms, we can just integrate each term separately. So we have x to the 1/2 integrated. We're going to have that, it's going to be x to the 3/2 over 3/2, which is the same as x to the 3/2 times 2/3. Okay, and then the next one is just going to be minus 2x, because the integral of -2 is just -2x. And then the last one, again, we're just going to add 1. So we're going to have x to the 1/2. Oop, we'll do that one up here. X to the 1/2 over 1/2, which is the same as x to the 1/2 times 2. And then plus c. All right, there you go. Anytime that I see that the degree of the top is equal to the degree of the bottom, or that the degree of the top is greater than the degree of the bottom, I know I can't do u-substitution because it won't cancel out right. So I know I'm going to have to do long division. So I know how much you love long division. Okay, so we have x squared minus x minus 1 divided by x squared plus x. So what does x squared goes into x squared 1 time, and we have x squared plus x. We change the signs, and we end up with negative 2x minus 1. And so that would be the same as minus 2x plus 1, because I just took the negative outside the parentheses. You know, I just did that thing. Okay, so we're going to subtract that whole thing, and then we have x squared plus x on the bottom. Okay, so now I can take the derivative, or not the derivative, the integral of this. So I have the integral of 1 minus 2x plus 1 over x squared plus x dx. And now I see, since I have the degree of the top is equal, or is less than the degree of the bottom, this is a really good candidate for u-substitution. I know this is just going to be x, so I'm just going to remember that for a minute. So let's do a u-substitution here. So I have u equals x squared plus x. Therefore du equals 2x plus 1 dx. Therefore dx equals du over 2x plus 1. And looky there, it's just going to cancel out, right? So I have, instead of dx, I'm going to have du over 2x plus 1. And instead of x squared plus x, I'm just going to have my u. Those cancel out, and I end up with the integral of 1 minus 1 over u du. Well, so this is just going to be... Okay, so I should have split those first. Let's do this, because it's not really, that's still, the 1 is still in terms of x, so this is 1 dx. Let's just go ahead and integrate that, because we already said we know how to integrate that. That's just x minus the integral of 1 over u. There we go. So that's going to be ln absolute value of u plus c, and my u was x squared plus x, so I have ln absolute value of x squared plus x plus c, and I have x minus that, so there we go. That's our integral. Okay, so here the first thought you have is you see, oh, I have a function and its derivative, but think about this. If I took this as my u and I ended up with 2x as my du, would it cancel this x out? No, because it still has a 3 here. So I would need my derivative of this to be 3 minus x or some term form of that, right? And I'm not going to get that. So let's go ahead and split this, right? Because as long as I keep this denominator intact, I can split this into 2 fractions. And then you might recognize that this would be arc sine. This kind of looks like arc sine, right? But I got to get rid of that x on top. So let's split it into 2 and we'll see what it looks like. So we're going to split this into 2 fractions. So we have the integral of 3 over root 1 minus x squared dx minus the integral of x over 1 root 1 minus x squared dx. Okay, so our first one is in the form of arc sine, right? Arc sine is 1 over square root of 1 minus x squared. So let's just bring that 3 outside, and then we have 1 over square root of 1 minus x squared dx. Awesome. So that one is just going to be 3 times arc sine of x, because the integral of this exact thing is arc sine. So that one's done. Easy peasy lemon squeezy. The other one's not quite as easy, but it's close, because you notice that I could take u and I could set u equal to 1 minus x squared, because now when I have du and it equals negative 2x dx, and then I have dx equals du over negative 2x, you notice that this negative 2x is now in fact going to cancel out the x on top, so we're in good shape. So let's go ahead and do that. I'll switch colors so that it's, you know, change it up. All right, so here we have x du over the square root of u times negative 2x. So the x's cancel out, and I end up with negative 1/2 on the outside times the integral of 1 over the square root of u du. Now let's simplify that, because the square root of u is really u to the 1/2, and since it's in the denominator, this is really u to the negative 1/2. Okay, so now I have the integral of negative 1/2 on the outside. Let's do that. Negative 1/2 integral of u to the negative 1/2 du. We just add 1. So this is negative 1/2 u to the 1/2 over 1/2. Well, 1/2 divided by 1/2 cancel each other out, and I just get negative u to the 1/2 plus c. And then I have to replace my u, and my u was 1 minus x squared to the 1/2 plus c. And then, since I was subtracting, I was subtracting this integral minus this integral, and this integral ended up negative, this is going to end up positive, and I'm going to have 3 arc sine x plus that whole integral. Okay. So just remember that when you separate a numerator, that's totally okay. You cannot separate a denominator. It doesn't work. You just can't do it. It doesn't make sense. And if you go way back to like 5th grade and think about this, if you're ever confused, you just recognize that you can't separate that. Okay, so how do we integrate something like this? Remember, that is going to be in the form of arctangent. Okay, so 2 more. If you notice here, I have some function in this derivative. Anytime I see cosine and sine in the same one, I think, ooh, let me just see about a u-substitution, because either it's a u-substitution or it's a trig substitution with the identity. So, but I see cosine and I see its derivative here, so that's a really good candidate for u-sub. So here my u is going to be cosine of 2x. Therefore my du is going to be negative 2 sine of 2x dx. Therefore dx is du over negative 2 sine of 2x. So here I'm going to have the integral of sine 2x e to the u du over negative 2 sine 2x. So my sines cancel out, and I'm just going to end up with negative 1/2 on the outside times the integral of e to the u du. Look how quickly that's simplified. What is the integral of e to the u? Well, it's just e to the u. That's why we use it. plus c, and then we're going to need to sub back in, so negative 1/2 e to the cosine of 2x plus c. Done. Easy-ish. Okay, last one. So the thing I see here is that I see some function, tangent, and I see its derivative, secant squared, so I think automatically, oh, probably going to be u-substitution. So let's rewrite this really quick as secant squared x over, if we think of this as tangent x squared plus 9, because remember that's the same thing. So my u is going to be tangent. My du is secant squared. Therefore dx is du over secant squared x. So I end up with the integral of secant squared x over u squared plus 9 du over secant squared x. My secant squareds cancel out, and I end up with 1 over u squared plus 9 du. Okay, so then we're like, oh, this looks really like an arctan problem, because arctan is 1 over something squared plus 1, but we're not quite there yet, so let's figure out, remember, we've got to get this to be like something squared plus 1, not something squared plus 9. So we're going to divide both of these by 9. So we're going to end up with u squared divided by 9 plus 1. We're just going to pull a 9 out there because, you know, if that makes sense, I just divided 9. So if I multiplied this 9 in, I would have this u squared plus 9. Okay, so that means my 1/9 can go outside my integral, and I have 1 over u squared over 9, which is the same as u over 3 squared, right? So that's the same thing. Because if I squared this, it's going to get to that. So now I am at, I should tack on my du. So now this looks like tangent or arctangent, right? Arctangent is the integral of 1 over something squared plus 1 du equals arctan of that something, right? So what is this something? We're just going to say this is the final integral is 1/9, and the integral of this is arctan of our something, which is u over 3 plus c. And then what was u? Now, our original one was in terms of x. Our integral now is in terms of u, so we need to switch it, so it's not in terms of u anymore. So we have 1/9 arctan, and remember that u was tan x, so we can write tan x over 3 or 1/3 tan x plus c. And that is it.